Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are going to talk about properties of the expected value of x and the variance of x, the random variable x, of course. And we are ushered in again. I'm on a bit of a Queen fix here. The classic rock and band Queen with their mega hit "You're My Best Friend," and of course we know mathematics is always our best friend. So let's get to it, shall we? All right. So properties of the expected value of x. So if e of x is the expected value of the random variable x, then the expected value of a constant is equal to the constant for any constant k. That makes sense. And if we have a constant times the random variable x, we can move that puppy out front and find the expected value and then multiply by k. And if we have a sum here, well, we can take the expected value of each individual and add that for the functions a and b. And there's some examples here of this. If you can pause it and take a look, it makes perfect sense. It's almost kind of like distributing. I don't want to say that. I shouldn't say that. But I just want to say right here, the expected value of 3 is 3. So this is equivalent to e of 3. And then we have some properties of the variance of the random variable x, and that is equal to the expected value of x squared minus the expected value x, the whole thing squared, or the variance of the random variable x is equal to the expected value of x squared minus the mean squared. Awesome. Here's a proof of that. If you want to take a look-see, go ahead and pause. I'm not going to waste time going through it. It's not a waste of time, but you can do that on your own. It's a very simple proof. So let's do an example. Suppose the random variable x has the probability distribution for x 1, 2, 3, and 4, and it has those corresponding probabilities. Okay, and here's the formulas as they appear on your formula sheet. So let's find the mean of x. Well, remember, the mean of x is equal to x. Remember, this is just like p sub I, right? It's equal to that sum. So if I took 1 times 0.1 plus 2 times 0.3, 3 times 0.4, 4 times 0.2, then I would get e of x is equal to, I'm not going to bore you with that arithmetic, which is 2.7, which would be, of course, equal to the mean mu. So what are we going to do about the variance of x? Well, we are going to use this wonderful formula right here, yes. So we have to find the expected value of x squared. We already have the mean, it's 2.7. So the expected value of the random variable x squared is equal to the sum of x sub I squared times its probability, right? Times p sub I, or the probability that x equals x, big X equals little x. Well, what does that look like? Well, that's no big whoop. That would be 1 squared right here times 0.1 plus 2 squared times 0.3 plus 3 squared times 0.4 plus 4 squared times 0.2, yabba dabba do, and you work all that out, and that is equal to 8.1, right? So now if we use this formula here, we have e of x squared, we have mu, so that means that the variance of x is simply going to be equal to 8.1 minus 2.7 squared, which I'm sure you can get do in your head as 0.81. So what would the standard deviation be? Well, standard deviation is equal to the square root of the variance. Square root of 0.81 is equal to 0.9. Oh, my friend passed away. Sorry you had to see that. I have to go to the funeral this Sunday. We'll save that for one day. Sorry about that. Okay, so next We have, I'm not going to go, there's an investigation that we can go through to show that these relationships are true. If I have the expected value of A times a random variable x plus B, I can rewrite it like this: A times the expected value of x plus B, and the variance of ax plus b is equivalent to a squared times the variance of x. And we'll talk about that in class. So let's say that x is distributed with a mean of 8.1 and standard deviation of 2.37. And if the random variable y is equal to 4 times the random variable x minus 7, find the mean and standard deviation of this y distribution. Okay. So what do we know? Well, we know that e of x, the expected value of x, is equal to 8.1. And we know that the variance of x is equal to the standard deviation squared. And we will use that to our distinct advantage. Okay, so the expected value of 4x minus 7 by this formula right here, boys and girls, would be equivalent to 4 times the expected value of x, and then just minus the 7. So that would be 4 multiplied by 8.1 minus 7, which is equal to 25.4. Yippee-ki-yay. And what about the variance of 4x minus 7? When I say x, you know I'm talking about the random variable x. I just am too lazy to say it over and over. And using this formula, it's equal to a squared, and my a is 4. So that's going to be 4 squared multiplied by the variance of x, which we know to be 2.37 squared. I almost just said 2.37. Shame on me. 2.37 is a standard deviation, so of course we have to square it to get the variation. You crank that out, and we get, what do we get? Well, I don't know what we get. I didn't work it out ahead of time, so we're going to leave it like that. But we do know the mean and the standard deviation of the y distribution. The mean is 25.4, and the standard deviation, oh, okay, so I'm sorry, we need the variance to get the standard deviation. I'm so stupid, I forgot that's what they asked. So we would take the square root of that. So the standard deviation would be the square root of 4 squared times 2.37 squared, which is equal to 4 times 2.37, or you can just crank it in your calculator like that if you want, which is equal to 9.48. All right, that is all I have. I hope you enjoyed it. We will rock on again to My Best Friend by Queen, and I am out.